Hello everyone, here is my Capstone project presentation with Kentecode AI Academy, and this is a RAG project. Project scope. I built the RAG project for students to help them find the requirements, WASI cutoff points, and a program they can read at KNUST based off the course they completed in high school with. I experienced this helping my younger brother select courses that are in line with what the university provides, and it was a difficult experience. So this project serves as a solution to help other students find the courses they can read with the programs they completed in high school with. Here is the problem with LLMs. We understand LLMs have limited knowledge on current affairs, and this makes them hallucinate, where they confidently provide wrong answers. For an example, let's take a fictional company like B&B Rice Company, where we have established that our refund policy is within 3 days because of the nature of rice. Now, assuming a user goes and asks an LLM about our refund policy, the LLM is going to generate an answer that the refund policy of B&B Rice Company is 30 days. Because the LLM is limited by its training data, it hallucinates by providing these answers, which are false. And so, with my project, I built two types: a simple RAG using LangChain and a production level RAG in Python. And RAG simply means retrieval augmented generation. Now I'd like to walk you through the simple RAG in LangChain. So for simple RAG in LangChain, we have two sections. We have the indexing section and the retrieval section. So for indexing, I load the data, I split the data into chunks, and generate the embeddings with OpenAI embedding small. And I store the data into a vector database. And a retrieval, I translate the user's questions into embedding, retrieve the relevant context, and we push the results to an LLM to generate a grounded answer. So we start. We load our environment variables, which we have here. We load the PDF, which is the data that we have for admissions, and here's the results. We split the PDF into chunks, into smaller units that can be converted into embeddings. So we see the chunks is 268, where LangChain provides a module for using to split PDF into chunks. So recursive character text splitter is what I used because it's the required to use. And we translate into chunks. So I load the embedding function, which is text embedding small from OpenAI embeddings. And this commented code is run for the first time when I am importing the chunks into a vector database, which is Chroma. So now that I've uploaded the embedded chunks into Chroma, which exists here, I read the data from Chroma, and it outputs exactly that I have 268 embeddings, which is exactly as the number of chunks here. And we retrieve the context. We retrieve the chunks. So we have a similar question like, what is the cutoff point for sociology? And so the relevant chunk for this question is embedded here. So we have other chunks that are related to this question. And now we generate. So we have our model, which is GPT-4o mini, and we import a system prompt where our LLM becomes an AI agent, a KNUST admissions assistance, an AI agent that helps prospective students find admission requirements. So this is a system prompt that helps the LLM to, it's basically a role-based prompt to help our LLM to manage the LLM's behavior. We then move on to formatting the output of the generated answer. So we have a question that says, what's the requirement for reading sociology? And it output by saying, to read sociology, WASSCE and SSC applicants must have credit passes in the following core subjects. And this is what it's listed here. So we have, this is a simple LLM using LangChain. So now I'd like to walk you through the production level RAG in Python. And for production level RAG in Python, I load the API keys, we clean and extract the PDF, similar process as our simple RAG in LangChain. We clean the data. In this step, we clean the data, we chunk the document into smaller pieces, and then we embed the pieces into a vector database. That's what we have here, and that's for the first part for indexing. And then we have the retrieval pipeline, where we work our way in retrieving the relevant context coming from the user's question. And this is what we have here as the code for helping us retrieve the relevant context per the user's question. And here is our UI. I'd like to show you the UI for the admissions assistant. So this is our UI uploaded on Streamlit. So let's ask an example. What is the entry requirement for reading computer science? So we have here the entry requirements for reading computer science are as follows. Student must have credit passes in English, mathematics, and integrated science. The students must also have credit passes in elective maths, physics, and either chemistry or applied electricity or electronics. These are the requirements for reading computer science. Let's say, can I read architecture with visual arts? And this is what we have. It says, yes, you can read architecture with visual arts. So you need to have credit passes in elective mathematics and any other two options. Now, this project is based off of only KNUST admissions program. So if we try to ask for questions in relation to other universities, let's see what its outputs. Can I read nursing with general arts? In University of Ghana? Simply says, I don't have that information, because we base off our retrieval context only on KNUST. And so if our LLM is not having that ability to answer, it only provides, I don't have that information. And this is the project that I built in Kentecode AI Academy as my capstone project. Thank you.